Japanese. I'm inclined to agree with that, but it's also not hurting us. I mean, if we see this in a sentence, then probably we should break that out as its own token. Okay. So now I'm ready to test my max match program. I'm supposed to feed it this dictionary file as an argument. Let's see, UD, and then there's my dictionary file. And it's supposed to print out the dictionary. And it looks like it printed out the dictionary correctly, right? I don't see any extra \n's or anything that would make me upset. Okay, so I can keep working on it. I have to write my tokenize function. So the tokenize function is supposed to take a sentence and it's supposed to use the max match algorithm to tokenize it. So now I have to think about this. I want to find the longest word which matches the beginning of the sentence. So if I'm always interested in the longest word, it's going to help if I sort my dictionary first. And I want to sort it so that the longest words come first. So here's how you do that in Python. You can use the sorted function to sort a list, and you can use the key here to tell it how you want to sort this key to tell it how you want to sort the list. And here's how I want to sort the list.
I think there is even syntactic sugar that allows you to write like key equals length.
Yep. Exactly right. Okay, so key, the way that it determines how what it should use to sort the words is length. Okay. So now I will. Okay, so I want to find the first word in my dictionary, which this sentence starts with. Okay. So here's my word, and here's how I'm going to find the word. I'm going to look over all the words in the dictionary which the sentence starts with. And I'm just going to, this next tells me that I'm going to find the first one. Yes.
So we assume here the sentence has already been separated into words.
No, the sentence has not been separated into words.
Just a string without
it's just a string.
white spaces in the middle without.
There may or may not be spaces.
Okay, cool. So shouldn't that be just we check the length of the sentence first? Try to match the word in the dictionary. If not, we reduce the size, then we reduce the size to find the longest word which may be found in the dictionary.
That's certainly one way you could do it. The way that I'm doing it is I'm finding the longest word that this sentence starts with.
How do you know that the sentence starts with something because there is no white space?
If the sentence doesn't start with a word, that's your worry?
Yeah, because we now what we got here is a string, right?
Mm-hmm.
Without white spaces into it.
Yes.
So we don't know where the sentence starts. Basically,
well, we know where the sentence
itself is the one word, is one string, right?
If it's one word, then we will find it because it will be the first, and it will be the first entry in the dictionary that the sentence starts with.
Please continue on.
Okay, so how does this work? My dictionary, remember, is sorted by length. So the longest words come first. This is going to search for the first word in the dictionary that is contained in the sentence at the beginning.
Okay.
So because it has to search through the longest ones first, the longest word will be found.
Mm-hmm. Oh, I see.
And now I will return a list which consists of this word and tokenizing the remainder of the sentence. So I want length of word to the end. Okay, and then I will print out the results. So for word and tokenized sentence, print word. Okay, let's test it. So how will we test it? I will do this. Oops, that's not helpful. And now I have to give it a dictionary file. Okay, there's my dictionary file. And I made some mistake, evidently. Syntax error. What is my syntax error? I ran Python 3, right? There, that's what I'm supposed to do. Stop iteration. It didn't find,
Because we have Japanese and English.
sorry?
The dictionary is in Japanese.
The dictionary is what? I just didn't hear.
No, she said in Japanese.
Oh, the dictionary is in Japanese, but I gave it this other dictionary here. So what it's telling me is that it didn't find any words which it starts with. And let's see. Probably I need to strip the. What do you think? Do I need to strip the sentence? Let's add some debugging output. Trying to tokenize.
Isn't it an infinite recursion? I mean, we did never stop our
Oh, that's very
recursion.
good. If the length of the sentence is 0, no tokens. And also, I should probably try to strip the sentence. Let's see. Okay, so evidently the sentence doesn't start with any word in the dictionary. Let me make sure that my dictionary looks okay. Dictionary looks fine. Okay.
Maybe we need to return an empty list when the word is an empty word. I mean, we can have think that, well, if the sentence ends with no word, how that will stop.
Okay, so I need to catch this stop iteration exception. And I'll just return the entire sentence as a token. There we go. Good catch. So maybe to make things clear, I'll include this special, get rid of this debugging line. There. And I don't need to print the dictionary anymore because we saw that that was working. Okay. So correctly tokenized now my hello there into hello and there. But I haven't tested that I've actually got max match working. I don't know that it chooses the largest possible word. So let me add some more. Oh, it found hell instead of hello. It should have found hello. Hell isn't a very nice thing to find. So I think that what I need to do is I need to reverse this. I think maybe there's a rev equals true. What do you think? Does it look like that?
No, just reverse.
Reverse.
Just write reverse. Without true.
Like this?
Yeah.
Okay. Nope. I think it's a
Maybe it's capital. I mean,
I think it's necessary to do something like this. There we go. Okay, now it finds hello. So now I have some strong belief that I've implemented max match because it finds hello instead of hell. So it really is finding the longer word. If you wanted, you could construct some other examples, some toys to make sure that you're really convinced that this is working, but I'm convinced. So now
could you explain one more what next does?
Okay.
Because I'm not the only one who still doesn't get this instruction.
Okay, so this is a computation saving device. Next takes an iterable. Iterable is, for example, a list. But in general, there are lots of different iterables. For example, you see this here. This for in construction uses iterables. There's not when you're running a Python program, and you're iterating over sys_stdin. There's not a list there. It doesn't know everything that you're going to type before the program runs. So it's taking them as it finds them. And the point of this next, using next instead of say making a list of this and then taking the first one, is making the list requires going through everything in the dictionary. This next, it iterates until it finds the first one, and then it stops. So you don't end up searching the entire dictionary multiple times. This will speed up your program a lot, especially if you have a large dictionary.
Excuse me, what is std in?
That's reading things from the pipe. So it reads one line at a time from the pipe. Or, for example,
командной строки.
Mm.
Ну, типа, ты подаешь из командной строки напрямую к этому скрипту, и он в скрипте это обрабатывается именно.
Mm.
so you see, I'm using this echo command, and I'm piping it, that's the pipe symbol, this vertical bar, into Python. If I didn't type that, if I just type, so I'll get rid of this. Now it's going to read lines. I can type lines into this, and when I hit enter, it will tokenize. It tokenized? Oh, it doesn't know any of those tokens. Well, it knows the word hell. So I told it Control-C to finish. Okay. Yeah, so I thought a little bit about this so that I would make sure that it was efficient and wasn't iterating over the dictionary too many times. Now we can try it on Japanese. Any other questions? Okay. So here's my dictionary dict file. And now I can type in some Japanese and it will segment it. It will tokenize it for me. Danny, can you? No, I'm just joking. Sorry, that was a joke. So you remember earlier there was some trouble with my keyboard being in Russian.
Yeah.
You offered to help, but now there's some trouble. My keyboard isn't in Japanese. Okay, no, I want to test this, and I don't actually know Japanese. And even if I did know Japanese, I don't know that I would know how to type it. So I'll use the test data set. So what do I want to do? I need to go into this folder, and I need to do two things. I need to extract the sentences to be segmented, and I need to extract the correct segmentation because I want to check how good a job I'm doing with max match. So let me take a look at this conlu format again. I see that there are comments that tell me the text of each sentence. So this is just the raw sentence in Japanese, and then what follows is the words that were extracted from that. So let me extract just the sentences first. So I want to get only, let's see, I'll use said, and I will not print most lines, but the ones that start with this text equals, I will print. Okay, so there's all the sentences in the test set. Let's see, how many are there? 557. Okay. I don't want this. I'm using my finger again. I don't want this comment text here because that's going to get tokenized otherwise. So let me get rid of it. Okay, so that'll get rid of it. There's a regular expression command to get rid of this. And okay, so now I have just the raw sentences. There's my sentences file. Okay. And now I want to extract the correct tokenization for the sentences. But we already know how to extract the tokenization from the conv file, so I'll find that. I think I did it in this tab, maybe? Yeah. Okay, I'm just hitting up and scrolling through my history. Okay. I have to get rid of the comments also, right? So let's see. Correct. Tokenization. And then I will delete the lines that start with comments on the test data set. Oops. I forgot the pipe. Okay, let's take a look to make sure that it looks okay. Yep, it looks fine. And now I'll run my tokenizer on it. Sentences. And the output will be to correct, max match tokenization. Uh-oh. I forgot that's not how I'm supposed to do it. I'm supposed to pass it a dictionary file, right? I forgot to pass it a dictionary. There's the dictionary. Okay, tokenized. So total, it found 550, 57, 557, that's something wrong, something is wrong there. Oh, I want to change a couple of things with this max match. First off, in the conv file, it doesn't have the quotes around the tokens. Okay. That's a little bit different. But there's blank lines now. So something's wrong. Did anybody see what was wrong? Let's see the first 10 items in the dictionary. The sort of dictionary. Well, that's very interesting. But it looks okay. Anybody who speaks Japanese, do you know if that's an actual word?
Аниме, карман, карманный монстр. Сейчас. Длинное слово сейчас. Или это вообще соединение слов. Непонятно сейчас слышно.
Is it at least
Это
possible?
this is like the set of words. It's nonsense.
It's nonsense.
Yeah, just set of words.
Okay, well, evidently it's interesting because it's in our dictionary, right? So that's very interesting. Let's see what we can learn about this. Well, okay, that's some actual like investigatory science. We're not supposed to be doing that right now, but it'd be very interesting to me to see if that makes any sense at all. We've got lots of years here. That's so cool. They're just wonderful. Okay, but it looks like that part is fine. So what could be wrong? So we read a sentence. That's fine. We tokenize a word. Seems fine to me. And let's take a look at our input file. Sentences.
It looks
Some
like
of them
it
start
will.
with spaces.
Yeah.
That's they all start with spaces. Now I see the mistake, right? The sentence if a sentence starts with a space, it never starts with a word. So the entire thing has to be one token. That's the mistake. Okay. So I need to fix my data set, right? Where did I make the sentences from? I did it in this tab. There's how I made sentences.
It doesn't have to be a token, the entire thing. It just has to split the space and then go on, no? Am I wrong?
Is your, I mean, that's a philosophical question. Like, is it still max match if when you run into a problem you have a one character token? So then I just need to change my code, right?
That's the way max match is supposed to work, no?
I don't know.
I thought so.
Like, it's max match. What I know is that it's supposed to find the biggest word that starts with the sentence.
Yeah, but if there is no word that matches the beginning of the sentence, it should click off the first word and then go on. No?
Okay.
That's kind of part of the algorithm.
Okay, well then I'll do this. Else word equals sentence 0, the first character. There we go. Okay, so see the change that I made? Instead of returning the entire sentence as one token, now I'm returning just the first character. Okay, not in this window, this window. There we go. And my output will be this max match tokenization. It's taking longer. I think it's a good sign. It takes a lot longer to debug things when you're thinking out loud. Okay. That looks better. So now, let's see. I found 20,000 tokens when using max match, and what was I supposed to find? 13,000. Okay. This looks like about a little better than 75%. I'll use my favorite strategy for comparing things. And use this diff program. So now you can get some idea. If you understand some Japanese, this is maybe very interesting for you. If you're like me, then it's just, there's symbols. But you can see what mistakes the max match was making. Okay, how did it work? So
it splits the grammatical elements.
I see. Well, because it's probably because of the dictionary that it had, right? It's just never seen this word before.
But it's very like very useful word. It's
I guess
it
so.
must be in such a big set of sentences.
Well, we can verify that it's actually not in our training data set. So let's do that. So this diff is putting out with plus signs the larger word that our max match didn't find. So let's select only those words that it didn't find, the error words, and let's get rid of that that leading plus sign. Oops. Okay. And now, for each one of those words, let's see if we can find it inside of the training data. UD train, conlib. So this isn't our training data. Something is wrong.
But these are parts of words in some cases, and in some cases just lemmas and not. But yeah, but in some cases it is word forms, so there's something wrong.
That's a very good point. Let's look for only when it's a separated, when it's its own word.
Так-то да. Понятно, что это подстроки, да. Некоторые из них целые.
Okay, so we're definitely finding these. So why is this not in our? Okay, so so we had this dictionary file, right? Let's look in the dictionary file. Oh, now I'm starting to understand. Well, something interesting is happening.
But not all of them.
Yeah.
Some are still even without the quotation marks, some are still missing. So it's not the only problem.
Yeah. By the way, at this point you're free to go. Now I'm just having fun. You at least saw me try to implement max match. You saw me fail. You saw what kinds of failures I run into. So you feel less bad if you run into them.
Yeah. But we want to see how you do with words error read here. How we do it. It's called with reader, yeah. Word.
Oh,
Error
well
read.
this is just computable, right? Like, I mean, you have a formula for this. You take the number of you take the number of
So we have hypothesis sentences and
Yes.
reference sentences,
Yes.
and we count it sentence by sentence, or how we do.
just add it up for the whole. Add up overall accumulate overall sentences. Like so you have the number right. You're supposed to do normalized Levenshtein distance, right?
Yeah.
So one way you could think about this is your program is inserting line breaks. Maybe that's a good way to think about it. How many line breaks does it insert divided by how many? That's the only thing it does basically. Your program inserts line breaks where it shouldn't.
Okay.
Right? If you're thinking about it as adding a line break at every token,
Yeah.
the correct answer has fewer line breaks than yours does.
But not necessarily,
Yeah.
I think.
Really? How would it have more?
Because so
Or sorry, fewer.
i-
Yeah, more.
if it's so it takes a longer word,
Mhm.
and then the next word, for example, it's like it well, accidentally it can also like because for example it took two words as one word, and the next word might be just might not exist at all, so it would
Yeah, will.
How would it take 2 words as 1 word though? In max match.
Yeah, because it's max match, right?
Oh, I see. They should have been split, and then
Exactly.
They weren't.
Yeah.
Sometimes
Yeah.
the longest isn't the better,
Mhm.
or otherwise max match would be perfect.
Mhm.
So and then the next symbol,
Mhm.
it was supposed to be maybe the part of that second word,
Mhm.
which appeared to be in 1 word in max match. So it would count as a separate word.
Yes.
But so it's kind of the same actually. It could be. I mean,
Okay, that's a
so
good point.
you never know.
Yeah. So, but the point is that there are some line breaks that are supposed to be there, and maybe there are some that aren't supposed to be there. Yeah. But those are both errors. So you just add up that number of errors and divide by the total number of words. I think that's the normalized Levenstein distance, right?
I don't know. I mean, it sounds more like what you're
Nobody knows.
suggesting is kind of shifting towards like precision recall stuff.
Mhm.
Like we measure the like false positive splits, and then we filter for like false negatives, non-splits, and then we kind of measure some sort of F measure, like harmonized precision recall. I mean that I can imagine.
Okay, so what would you expect then?
I mean, I would try to. I mean, if I was implementing like this evaluation of tokenization myself, that's what I would do. I mean, I would look for splits which are there, which aren't supposed to be there, and count them as like 1 type of errors, and then and use it to calculate, say, recall,
Mhm.
and then to calculate precision. But I don't know if it's correct. I mean, it's like the thing to do here. Because I mean, to implement the actual word error rate, I think it's a bit more complex. Exactly because you can have more or less words.
Yes, but there's no. I mean, there's a correct number though.
There is a correct number, yes.
Yes,
But
and that's what
your
we're supposed to
sentence can be
divide by.
shorter or longer. Right?
But I look at it as just like this isn't an error rate in producing language. This is an error rate in sort of producing a stream of symbols. And the stream of symbols is words, and you're never going to with a new line terminal, basically. And sometimes it's going to include it's going to have the wrong word with new line terminal. So you can just really compute this normalized Levenstein distance.
Maybe we could also have a program, hypothetically, that compares the outputs symbol by symbol, and then, well, somehow like it determines that this word, like these words, were not determined correctly by
Yes.
well, I don't know how it might work, but I think that it might work.
Yeah,
Like
absolutely.
smarter than Levenstein.
Mm-hmm. Yeah, I think that as long as you can explain the algorithm that you're using, that's what we're looking for. I mean, any particular person's algorithm